right, good day to you, my viewers. My name is Dr. Abimbola and I'm explaining to you in simplicity the mechanism of reactions. When you talk about the word mechanism, um, what comes to mind is mechanics. Mechanics. The mechanism of reaction actually talks about the how of a reaction. So the how of a reaction. How did it occur? How did the reaction happen? So it's the how. Whenever a reaction occurs, there is usually the bond breaking part of the reaction, and on the other hand, as the products are being formed, there is the bond formation. So, so the bond breaks and so new bonds are formed. But how do we depict this mechanism? How is it depicted? We need to be familiar with some terms. Of course, you know that when I have um, something like this in a bromine molecule, you are aware that this bond that is here, this single covalent bond that I have here, actually consists of two electrons or a pair of electron, an electron pair. But which kind of electron pair is this? This type is a bond pair. Okay, you have some other types of pairs like lone pair. Okay, this is called the bond pair. It can also be called the shared pair. So how do we depict the movement of electrons? When you have a half-headed curly arrow, because actually we're going to be using curly arrows a lot in depicting mechanisms. So when you have a half-headed curly arrow, it means that a single electron, not a pair, a single electron is moving. However, when you have a full-headed curly arrow, it means a pair of electrons is moving. Is moving. Okay? For instance, in the bromine molecule that was written in the previous page, if I have a half-headed curly arrow coming here and another half-headed curly arrow coming here, what this means is that the first bromine atom here takes back the electron it contributed when that bond was being formed, and the other one as well does the same. So the bonds are the bond is broken. So it means that single covalent bond that holds one bromine atom with the other is no longer in existence. This kind of movement of electrons leads to what you call homolytic cleavage. homolytic cleavage. Homo means same. So you would see that the bromine with a dot, that dot is the electron that was in the bond, and the bromine, the electron here, is also the electron on the bond. So they are similar, homolytic. But it's important to also note that there is another type of cleavage that the bromine molecule can undergo. Okay, it's possible to have a full-headed curly arrow, a full-headed curly arrow moving into the top of one bromine uh, atom. So in that case, what happens is that you have this bromine now having a pair of electrons on its own head, apart from all the other pairs that have been there. And then the second bromine atom now seems to be without an electron that used to be is. Okay, this is because when they were forming this covalent bond, this particular covalent bond, when they were forming this covalent bond, the fourth bromine one donated an electron, the second bromine donated an electron, so they shared. But now it's like there's a divorce, and then and as the divorce is taking place, it's only one bromine that took the two and put upon his head. So technically, this bromine atom has lost an electron, and then this one has what, gained an electron. You may want to say it has gained two, but actually one of it was originally donated by itself. So technically, when you look at it, it's as if this one has gained one. So that's the reason why this type of cleavage is represented as, you see a minus on top of it. The minus sign means there is an excess. There's an excess electron. Okay, and then this one would now have what you call a positive a positive sign on top of it, showing that it has lost an electron. Okay, now please understand that this type of cleavage is called homolytic cleavage. Sorry, hetero. Yes, because they are different. This type is called heterolytic cleavage. It's called heterolytic cleavage. Okay, I'm writing that again. So this is called hetero. Hetero means different. So this one is Br minus, this one is Br plus. So you call it heterolytic cleavage. Okay, so with this, you have an idea of how bonds break and the use of curly arrows in this kind of convention. It's also important to note here that this type of species that has a negative sign, excess of electron, is known as a nucleophile. While this type of a species that is deficient already in an electron is known as an electrophile. Nucleophile is from the word nucleus. The nucleus of an atom is positively charged because it consists of positively charged protons and neutrons, which are neutral. So the charge of the nucleus is positive. So in the convention that expresses reaction mechanisms, a positive center is usually known as a nucleus, while a negatively charged center is known as an a negatively charged center is known as a nucleophile, yes, and a positively charged center is known as an electrophile. So is looking for electron. Electron file. File means love. Nucleo file. File means love. So nucleophile, that is nucleus loving. We'll talk about this in the next video. An electrophile, that means electron loving. So let me write this here. This is nucleus loving, and then this one electron loving. Okay. Um, with this, I'll just show an example of how you may need to identify some of these uh, species by yourself. I'll just write a few things here, and then you can play around with it. CH3 plus, Cl minus, F minus, and and OH minus. Which one of these would you call an electrophile? Electrophile. Which one of these would you call an electrophile? Of course, this one that is positively charged. Okay, and then um, just one more. If you have the benzene ring, if you have the benzene ring, and then you have the electrophile, the one that was identified in the previous page, which will first attack what? Remember, this is about reaction mechanism. How do we depict it? Usually, the arrow must move from the region that is electron rich to the region that is electron poor, because it's usually the electron making the electrons making the reaction to happen. So because this benzene ring is rich in electron, one of these will come and attack here. Okay, and that um, initiates the connection between the benzene ring and the methyl uh, carbocation. With this, we have come to the end of the first video, which seeks to just show us that um, you can depict what is happening in an electron, and from there be able to tell how a reaction is supposed to occur. So, but as I stop, I'll just ask you, with this, what is moving? Only one electron is moving. And with this, what is moving? Full-headed curly arrow. A pair of electrons is moving. Thank you for listening, and see you in my next video.